Good afternoon, all of you. Well, good afternoon or good morning, depending on time zone you are in. So, welcome to this webinar about the implementation of Wi-Fi 6 and Wi-Fi 6E and its impact on the structured cabling systems. Well, first of all, it looks like a little bit like a contradiction to talk about Wi-Fi and cabling. As Wi-Fi is cable-less. So, well, yes, but not really. It's not a contradiction. Wi-Fi let us connect equipment wireless to an access point. But this access point needs cabling to connect to the network. So, and we are going to look at it a little bit on this cabling. What is the impact of deployment of Wi-Fi 6 and Wi-Fi 6E on this cabling that connects the access point with the network? So, first of all, what is, sorry, one moment, please. Okay, I need my spotlight again. Perfect. So what is Wi-Fi 6 and Wi-Fi 6E? Well, it's a brand new standard that should have been ratified this spring, but due to the problem with the coronavirus, it has been delayed. So the standard is approved, but it's not ratified, which means it's not signed to be published. So that will take a little bit longer. But this new standard is IEEE 802.11ax. Well, it's a new standard that comes after the 802.11ac that we had before. And this AC standard would give us the 5 gigahertz band as a Wi-Fi solution for Wi-Fi implementation. And the 6E, as you see, uses 2 bands, 2.4 and 5 gig completely. Well, you can say, well, I have an access point that's AC and it has the 2 bands, 2.4 and 5 gigahertz. Actually, this 2.4 was defined by the standard 802.11n. So it, let's say, it's a less fast protocol. So if we look at the difference in between, well, first, another thing before I go further. As you see, we refer now the standard like 802.11 AC as Wi-Fi 5 and 11 AC as Wi-Fi 6. This is because the Ethernet Alliance and IEEE understood that talking always about 802.11ax and or AC, it's not very commercial. So it's very much easier to talk about Wi-Fi 5, 6, or even Wi-Fi 4 for the N version. So that's why we can talk now about Wi-Fi 6. If we look at the channels used between Wi-Fi 5 and Wi-Fi 6, there's no much difference. They use the same channel with although the FTT size, so the fast Fourier transfer size, it's bigger on Wi-Fi 6. This means that we can cover a bigger spectrum to acquire a bigger spectrum with Wi-Fi 6, and this will lead to the possibility to have a higher modulation, like we see. We go up to 1024 QM, and also a bigger transmission rate. So we go up to 10 gigabits per second in Wi-Fi 6. Well, what's the difference between Wi-Fi 6 and 6E? Well, 6E adds also the 6 gigahertz band to the 5 and 2.4. Well, this 6 gigahertz band is not straightforward. So it means that in some countries, this 6 gigahertz band is used for other applications like weather radars or point-to-point radio connections and so on. Depends from country to country. We had a news a few weeks ago that the FCC from the United States has freed the 6 gigahertz band to be used with Wi-Fi 6. In other countries, there may be coexistence between different applications on the same band, and this will put restrictions like power use and so on. But okay, that will depend on the implementation on each country. So it's not guaranteed that in every country Wi-Fi 6E can be deployed. That will depend on the local telecom regulations. Well, what advantages will give Wi-Fi 6 and Wi-Fi 6E? Well, first of all, we will be able to connect more equipment than before. And also there is a need for that because there are more and more equipment that we connect to an access point, not just a laptop, not just a mobile phone, but even like a dishwasher or any type of appliance, video cameras, surveillance cameras, so IoT. So there will be a lot of equipment connected. So Wi-Fi 6 will be able to have more of these single connections. It will have a better energy efficiency, not only on the access point, but also on the equipment connected to this access point. So it will lower the energy demand of this equipment. That's also a big advantage. We will have more bandwidth. So, and this more bandwidth will let us also have more transmission speed up to 10 gig. And very important for control systems, we will have less latency in the whole setup. And another important thing is that we were used when with the former Wi-Fi standard that as we would go up in the standards, the reach, so the distance we could reach with an access point will be less. And it had also less capacity to go through walls and so on. Well, this disappears with Wi-Fi 6 because it uses what we could say beam transmission. So it finds out where the mobile equipment is that it's connected to it, and it will concentrate its beams so that it has a bigger, longer reach. So although it's not a ratified standard, a lot of Wi-Fi access point manufacturers already have access point on the market with the standard of Wi-Fi 6. If you put in Google access point Wi-Fi 6, you will get a huge list of access points. Well, I did the same, and the first I got was this Huawei Air Engine access point. So, and what I really was interested in is the next page, that is the specifications. And if we have a closer look to these specifications, we found out that this access point is using DC power. so direct current power, and it complies this direct current power with PoE of the standard IEEE 802.3BT. Well, probably you will know it better as PoE++ or high power PoE. We will come into that later. So, and it uses also two electrical ports, that means two copper ports that go up to speeds with till 10 gigabits. And it has also one fiber SFP plus port for 10 gigabits over fiber. So we could say, okay, then we can use this access point over fiber. Well, yes, but you will need also a copper connection because you need to give it a PoE. So at least we will need one copper connection, and we could use an additional fiber connection to have more bandwidth to this access point. So we see also in the protocols that it is backwards compatible, so I can connect to it AC Wave 2 or N protocol devices. And the transmission rate goes up to 10 gigabits. So if we want to deploy this access point, first of all, we need to support PoE high power that goes from 45 to 90 watts, as we will see later on. We will go a little bit deeper into what this PoE standard means and what the impact is on our structured cabling, or how do we have to design it, or what do we have to take into account. So if we want to have structured cabling ready for Wi-Fi 6 or 6E, it must support 10 gigabits, first of all. It can be a copper, or it can be copper and fiber. And it must support high power PoE, 45 to 90 watts. So what does it mean that it has to support 10 gigabits over copper? Now it means that at least we have to install category 6A as a completely minimum. But we can go further up and install Cat 7 and 7A. Later on, when we talk a little bit more over power, over Ethernet or PoE, we will see what the benefits are from installing Cat 7 or Cat 7A even instead of category 6A. But as minimum, we have to use category 6A. Okay, 10 gigabits over fiber, so we have the opportunity, we can use OM3 or OM4 fiber. OM3 will give us a reach of 300 meters and OM4 450 meters. As you see, I don't talk here about OM5 because it's for me, it's not really an option when I want to support 10 gig. If I compare it to OM4, OM5 will give me no more length reach than OM4, and it will be more expensive. So OM5 is beautiful, nice if I go to 40 gigabits, but not for 10 gigabits, doesn't have any advantage. I could put here another type of fiber that would be single mode OS2 fiber, and that will give us a reach of 10 kilometers. I didn't put it in here because, but normally the SFPs related to single mode fiber are more expensive than the ones for multimode fiber, although the price difference is sharply going down from month to month. But it could be also a possibility to use OS2 fiber. So What does it mean that it has to support high power PoE? Well, that means that we only can use copper. We can use a fiber link to, let's say, support or add it to it, but at least we need one copper link. So, and if we use PoE, especially high power, we have to take some considerations that we will have deeper into it a little bit later on, but we have to take into account that the copper conductor diameter will be important, as with a bigger diameter we have less resistance, less loss, less cable heating, and more reach. Well, why do I say more reach? We are all used to use the 90 meters for a permanent link, 100 meters for channel configuration as the maximums we can use in a network. Well, that's true for 95%, but in some cases it's not. Well, one case would be if we want to use more than the 5 meters that is allowed of patch cord cable in a 90 meter, 100 meter scheme. So if we want to use, let's say, 25 meters of patch cord cable, we can do it, but then we cannot have a permanent link of 90 meters. And so the standards really don't define a fixed length. They define tables that we can use to calculate the maximum length of the permanent link. So in these tables, one of the parameters they use is the temperature. So all these lengths are standardized on 20 degrees. So if my cable is on 40 degrees, then these 90 meters are not correct anymore. So I have to reduce it to less. Well, in a made installations, I cannot do it. If the cable's already installed, I cannot do it. So the only point I can do it is when I design the installation. So if I'm designing an installation that's going to be used a lot of PoE or high power PoE equipment, I have to take into account the temperature rise in the cables. So, and this temperature rise will depend on the copper cable I choose for the whole installations. Not only the copper cable is important, but also as we will see, how we bundle these cables, and also the construction of the cable, like do I use a shielded cable or an unshielded cable? That will have an impact. We will see that also later. And watch out, the connector. Connector is also very important, has to be able to support PoE. We will see that a little later on detail. One thing I mustn't forget if I deploy PoE is the sizing of the backbone. That's very important. So if I deploy on a floor 10 or 20 access point with 10 gigabit, I cannot give these access point a backbone of just 10 or 20 gigabits. It must be much bigger. So I can do it by two ways: by incrementing the amount of fibers. So with link aggregation protocols in the switches, I can make from several fiber links one big fiber link with more transmission capacity, or I can use higher protocols, and in OM3 and OM4 fiber, I can have 10, 25, or 50 gigabits at this moment with LC connectivity. So it would be good thing is to size correctly the backbone and give it LC connectivity to be able to upgrade this backbone as long as I'm going need it from 10, 25, 50 gigabits. In the design phase, I have to take into account that the maximum length of these backbones, that will be 10 gigabits, for 10 gigabits, 300 meters, for 25, 70 meters, and for 50, 70 meters in OM3, and OM4 will be 10 gigabits, 450, and for 25 and 50 gigabits, 100 meters. So, as we see, PoE will be very important. So let's take a closer look to PoE and how we can prepare the structured cable system for PoE deployment. Well, first of all, what is PoE? Well, PoE stands for Power over Ethernet. So what we do is we send data and power over just one unique link. Over the same cable. In a PoE system, we can define two types of equipment: the power sourcing equipment, so the PSE. The power sourcing equipment is the switch or the midspan that injects the power with the data. And then we have the power device. So that's, let's say, the customer, the client, the device that uses that power, or the PD, power device. So, and how can we implement a PoE? Well, that will depend on if we are using an existing network or a completely new network. So if we are going to a completely new network, the right thing to do is that we use a PoE switch, so a PoE enabled switch, and PoE powered devices like cameras, access points, or whatever. So, and then for the infrastructure, we only will have a normal cable link without anything else. If we are going to an existing network and we want to add PoE, and we already have switches installed and we don't want to spend money in new switches, we can use an injector. So injector we will put between the switch that doesn't have a PoE and the powered device, and this injector will add to the data that comes from the switch, will add power to it and transport it to the powered device. Well, in the powered device, we can also have two situations where we have already a power device that is PoE enabled, so then we don't have to do anything. But if we want to reuse a camera or an access point that doesn't have a PoE entrance, we can have a splitter that splits the data and the power in two parts and send it to the powered equipment. From one part the data and from another part the power. So what standards do we have for PoE? Well, PoE is not really new. It's already there from 2003 on, where we had the first standard, that was the IEEE 802.3 AF, and that standard would define three classes of PoE, class 1, 2, 3, very original, where we had the first class would give 4 watt on the source, but there must be 3.84 watt at the power device on a distance of 30 meters away from the source. The second class would give 7 watt and 6.49 watts on the power device. And the third one, that would give 15.4 watt and 13 watt on the power device. And this standard was prepared to be used with Cat5e cable. As you can see, on 2003, we already had Cat5e in place, so that was no problem. And this standard is mainly used for Wi-Fi, surveillance cameras, voice over IP phones, or and initially also for IoT devices with low power consumption. Well, this standard was quite a success, and a lot of new equipment came on. And as new equipment came on with PoE enabled, also the need for high power went up. So in 2009, PoE Plus was released with 30 watt on the source and 25.5 watt on the power device. And this was already enough for surveillance camera with positioning system or heating inside the camera, or video conference systems, IoT with more high power. Well, before this standard was adopted, one of the issues that was brought up was cable heating. It wasn't really taking into account when PoE, so the standard PoE was released, but when they were studying to release PoE Plus, they studied very deeply how the cable were heated when they used 2-pair or 4-pair power transmission, and what type of cables and what bundle types were most suited to be used for PoE. Although we still see it was projected, or it was designed to work also on Cat5e cables. So recently in 2018, PoE++ or high power PoE has been released. This one defines 4 new classes. They go from 45 watt to 90 watt. It also already demands Cat6 cable, so Cat5e is not good enough for this high power cables, and it has a lot of potential applications. We have seen it already on the high-end Wi-Fi systems like Wi-Fi 6, but it also has been used for Wave 2 Wi-Fi 5 standard. It's also suitable for LED illumination or LED lighting, and it means that we also for LED illumination we can do it with one single cable and also in the control of it. Digital signaling, that's also very hype at this moment. The digital signaling is all the TV screens that we see around hotels, in shops, in malls to indicate the way of certain things, or in bars where we can see what the menu of the day is and whatever. And these are network connected devices, normally over cable, and they can also use PoE. Point of sales or vending machines can also be used. Another application is for laptops, and this means that we can get rid of the powering devices for a laptop that even consume electricity when they are not powering anything else. And IoT, that will be also more and more energy demanding. So what are the advantages of PoE? Yes, Pedro.
You are seeing me. I have here a question from Jorge Gonçalves. I think that if you go further, the question can lose some importance. And he says, or he asks, doesn't 2.4 gigahertz travels farther and 6 gigahertz faster?
Well, 2.4 gigahertz, if you compare it, the one used in 802.11n had a bigger reach than the 5 gigabits used in 11AC. That was true. With Wi-Fi 6, that's not true anymore. 2.4 and 6 and 5 have the same reach because of the beam bundling. So it means that I can have several beams that go into a device and have through that a bigger reach because I will have less interference. It's not anything else.
I think that could be the answer that George needs. I don't know well, but if he needs other information, he can chat and we will ask again. Okay.
Okay, perfect.
Okay, thanks.
So advantages of PoE. Well, the advantage, first of all, is that we use only one cable for electricity and data. So it means it's an easier and faster installation, and it reduces the overall installation cost. That's very obvious. But it has more possibilities. It gives us a way to remote turn on and turn off equipment. We can use it for turn off and turn on equipment that has been in an unstable state, so we can remotely reset it, repower it. Or we can program or by groups or individuals equipment to program to switch them off during the night where, for instance, the access point, we can switch them off over the night when nobody is at the office. So that this means that we can also contribute to energy efficiency in buildings. And this management or programming, we can do it by the management software of the switch, PoE switch, or we can use a management system of the equipment and themselves. It makes it easier to move the installed equipment. If we have to change the location, it's much easier, and especially if we use NPTL links, as we will see later on. We can install easier equipment on very complicated places, as we only have to bring one cable, and we can use it with outdoor equipment, outdoors, also with outdoor copper or fiber cable. So we saw already that power Ethernet will have impact if we wanted to do it right on the cable, also on the connector. We will see that we will have also influence on the cable placement, how we bundle it, and where we transport it in, like how do we use trays or conduits. So in the cable, it's very important, as we will see, the cable diameter, the resistance per kilometer, the resistance imbalance, and the cable construction. So we have a closer look to that. So the conductor diameter, we have to take into account that we are using DC power. So DC power uses all the diameter or the area of the conductor to be transported in as a difference, as a high frequency signal that only uses the skin of the conductor. A DC power will use a whole area. So as we can see, the resistance to this power of the copper cable will depend on the cable diameter. As bigger the diameter, less resistance we will have. That's straightforward. So normally we use AWG as conductor diameter standard that we borrow from United States friends, and this diameter standard AWG is not, let's say, a continuum of diameters. It's more defined in steps. So AWG 23 will span from 0.54 till 0.6 millimeter diameter. So we will have to take that into account when we look at a data sheet. It's better to look at the diameter in millimeters. Will give us a better indication than the AWG. So, and the diameter, we can see that is directly related with the resistance per kilometer. So as bigger the diameter, less resistance we have per kilometer. So that's a second parameter we have to take a look at trend. So as we have a lower resistance per kilometer value, a lower resistance of the complete link we will have. That's very obvious. So, and the resistance of the link is important because we will have a Joule effect in it. So, and Joule effect is simply the generation of heat when we put current, electrical current into a cable. This generated energy or emitted heat is directly proportional. We can see it in this equation that this emitted heat is proportional to the square of the current, electrical current, multiplied by the resistance, multiplied by the time this current is flowing. So it means that the emitted heat is directly proportional to the resistance of the cable. So bigger diameter, less heat generated. Well, IEEEs give us a maximum for the resistance of the channel and the permanent link. Although they define it as the loop resistant, that means that is the resistance in one pair using one conductor and then making how do you say it? Across between to the other conductor and back again. So making a short and back again. So that's the the loop resistance. So for a channel, it's maximum 25 ohm. That will mean that for one conductor up and down will be 12.5 ohm. And for the permanent link, that's one, let's say, one cable from connector to connector. There we have maximum of 21 ohm in the loop. That means 10.5 ohm per conductor. So that will give us already one indication that we have to look at the data sheets. Another important point is the resistance imbalance. The resistance imbalance, we cannot define it, or we can define two resistance imbalances. The first of all is the difference between the resistance in the conductors of the same pair, of one pair. And we can have also a resistance difference between pairs. Well, the origin of these differences, of these imbalances, are directly related to cable quality. Depends on the conductor diameter homogeneity. So how, if the diameter of the conductor is completely equal, is completely the same over the whole conductor length, then we will have less resistance differences. Also, the copper quality is important, as copper always has some dopants, also will have some, let's say, dirt in it. How better the copper is, less differences we will have in the resistance. And here I want to make a short break just to say one thing. In some market, it's very often to see copper-coated aluminum cables, CCA cables. Not to, I don't mean CCA standard for CPR, so copper coated aluminum. Copper-coated aluminum is not standard. The standards doesn't allow copper-coated aluminum. It has to be pure copper. It will have a higher resistance, so we will have a resistance in a problem in our loop, and also the resistance imbalance will be much higher. So it's very unlikely that a copper coated aluminum cable will work with PoE. Sorry. So if the imbalance is high, PoE will not work. Okay, I forgot one point also for resistance imbalance source. That is the difference in conductor crimping on the connector. So if the connector I use is using a mechanism that is punching down one by one each conductor, I cannot guarantee that the conductors are crimped equally on all of them. So I need to use a tool that crimps all the conductors at the same time with the same force, and that it is introduced the same way in to the IDC contact. So that's very important. IEEE 802.3 also gives us a maximum for the resistance imbalance, and says that the resistance imbalance between conductors has to be maximum 3%, and between pairs maximum 7%. So as I said, when we passed, they were studying the PoE plus standard. One of the things that was worried everybody was how the impact of cable heating would be in different cable types as we push through it DC current where it originally was not intended for. So what was seen very quickly was, first of all, that the cable diameter would have an impact. We've seen that already, but so a bigger cable conductor diameter, less resistance, will get less heating, but also the construction of the cabling showed to be very important, as a shielded cable gives less heating than unshielded cable. This is because of the shielding is working also as an isolator. And in the next table, we can see a description of the heating in 2 pairs and 4 pairs power transmission of different type of categories of cables and constructions. So This was made with bundles of 127 cables. That was the test that was done at that moment. And from this table, we can see as we go up in category, we go down in temperature rise. Logically, if we put more current into the cable, the temperature rise will be bigger. So if we put 4 pairs instead of 2, also the temperature rise goes up. But from this table, we can also see, that for the same category, unshielded cable would have more temperature rise than a shielded cable. So here in this case for category 5, almost half of the temperature rise. So, yeah, another important part is the connector. It's first of all, it's better to have a mechanical connector because a mechanical connector will dissipate more easily heat than a plastic connector. So a connector with a complete metallic body will be the best for it. But it has also to comply to 2 particular standards that are from the IEC, the 6512/9/3 and the /99/001. These 2 standards are used to verify that a connector is PoE capable. Well, why we need PoE capable connector? When we disconnect a power device, so if we pull out the patch cord from the power device, in the moment that the contacts of the RJ45 plug and jack start to separate from each other, a small arc will be produced. This small arc will impact on the copper contacts and will slowly on degrade this contacts. So these contacts will get dirty, let's say, and at the end there will be no good contact for data. So normally when we look very closely to PoE enabled connector, we will see that the contacts are banded that way that the first, let's say, contact point is not the same surface as the data transmission surface. So this means that we are not transmitting on the spots where the arc will be impact on the conductor. So it's also very important to look at this specification. With high power PoE, we also started to study how is the heat release within a cable bundle, because that's not uniform. If we look at, for instance, this 19 cable bundle, we'll see that the heating of the cables, it's much higher in the center of the bundle than on the outside of the bundle. This is because cables inject heat in each other. So it's very logical if we have more cable bundles like we see in this graph. As more bundles we have, bigger the temperature rise in the bundle will be. So more cables in the bundle, more cable heat produced, especially in the center of the bundles. But how we place the bundles is also important. So not only the bundle size, but also where we place them. So if we place them in the way that they are completely ventilated, the bundles, then the temperature rise will be moderated. We use small bundles. If we have them partially ventilated, so we put them in a tray without a top on it, then depends on the cable or the bundle layers we have. If we just have one layer, then the temperature rise will be less than if we put several layers of bundles. So as we see where the bundles touch each other, there the temperature rise will be bigger. And if we compare it to completely ventilated bundles. If we put the top on the tray, then we see that our bundles go up on temperature. Or if we use conduits, like in this case, and we fill up the conduits with copper cables, also the temperature rise will be big. So talking about trays, and there will be also difference if we use metallic or plastic trays. If we use metallic trays, metal will dissipate heat easier than in plastic trays, so that will be better. And we already seen closed trays. We can use them, but with very low cables, it's better not to use closed trays. And in conduits also we can use conduit, but with very low cable count, don't fill them up. One thing, and going back to the cable trays, okay, don't forget, if we use open cable trays and we have electrical conductors by, we have to apply, we have to take into account the needed distance to this electrical conductors that we have to take into account on the sign. We know that if we use shielded cable, this distance is less than if we use unshielded cables. So because we use electromagnetic immunity, if we, let's say, don't close the metallical trays. So, so in overall, what are the recommendations for POE? So use and also we can extend that to Wi-Fi 6 and Wi-Fi 6E, is to use category 6A cable as a minimum, but better category 7 or 7A cables. Use shielded cables because that will lower the temperature rise of the cable bundles. Do not use bundles at all if it's possible, so let the cables loose in the cable tray, or use small bundle with Velcro ties instead of normal plastic ties. So with Velcro, we will not be able to have very tight bundles, so we facilitate the airflow between the cables. Use open and metallic trays, and don't fill up trays or ducts, and use metallic connectors, metallic Cat6A connectors. So till a few years ago, if we want to make a link to an access point, we needed to use a jack in our patch panel, a jack on the end of the link into an outlet that we place somewhere, and a patch cord towards the access point or the equipment that we want to power. Well, this is not very easy to do. It's less flexible, and at the end, in some cases, people would like better to plug terminate this link. Well, we can do it now, and these links are called MPTL links, so modular plug terminated links, and they look something like this. We will have a cable, and in one end we will have an RJ45 jack, and on the other side an RJ45 plug. These links are described in TIA 568/2.d, and it's in a draft in ISO. If you're looking to Senelec, the European norms, Senelec is at this moment not working on a draft for MPTL links, and they are not working on it just to not duplicate the work that's ISO doing, because once ISO will release this MPTL link standard, they will just copy it. But we can already start test these links and do these links following the TIA or the TIA standard or the ISO draft. So what would we have? We would have a PoE switch. With a patch cord, we go to our patch panel, and then we have a jack plug link that go directly into my Wi-Fi access point, video surveillance camera, point of sales, digital signaling, IoT, or whatever I want to connect to. So what can we offer in BARPA for MPTL links? Well, the complete solution. We have the metallic jack, we have the cable, and we have the RJ45 plug. So you can make with BARPA a completely MPTL link. And also you can test it. Many manufacturers of test equipment have already MPTL link in place. For this MPTL link test, we will use, a permanent link adapter on one side in one of the equipment, and on the other side we will use something similar to a channel adapter. It's not completely a channel adapter, because a channel adapter, if I have a channel adapter for category 6A, I can use it with Cat6 or Cat5e without a problem. Well, for MTPL links, I need a plug adapter for every category I want to test. So they are different from category 6 or 6A. So if I normally install these both category, I need two plug adapters. Well, what can we offer BARPA as solutions for Wi-Fi 6 implementation? Well, first of all, we have a full range of shielded cables. As we have seen, that's the best solution, starting from Cat 6A, Cat 7 or 7A. Even in Cat 6A, we have two different types of constructions, UFTP or SFTP, depends on what you prefer. And for outdoor applications, we also have a Cat 6E with PE sheath, so we can also have outdoor implementations with the BARPA range. And we have the Cat 6A shielded metallic plug and jack. We'll have a look at it. So let's take first a look at the Cat 7A cable, just as an example. We have here the data sheet, and there we can find some of the data that we talked about that's important. So first of all, the diameter of the conductors, we can see them. we not only give the information on the AWG, but also we give the information on the cable diameter. And also the DC resistance. We give it as ohms per 100 meter, but as you remember, for a 90-meter link, permanent link, we had the maximum of 10.5 ohm, and we see that we give in our specification, we have a DC resistance of less than 9.38 ohm for 100 meter. And also the resistor imbalance. For this is the resistance imbalance between conductors of the same pair. We see it's less than 2%. So we comply completely what you need for high power PoE and deployment, and in consequence Wi-Fi 6 and 6E deployment. So in the copper range, as I said, we have also our shielded connector, category 6A, completely metallic body in keystone format. It's toolless installation. It has a built-in tie. It's reusable. We have a Delta certificate for it, so means that it's certified production, and it's part of our 25 years warranty system. Also for the plug, we have a field termination plug, the leader. It's a completely metallic plug, shielded, category 6A, metallic body. It's reusable, so if we make a mistake, we can redo it. It has a long release latch, so it's for easy installation in difficult to access access point, and it can be used for solid and flexible cable. We talked about the backbones. So as we said, the best solution for Wi-Fi 6 and Wi-Fi 6E backbones is to oversize the amount of fibers. So we today only will use 4 fibers. Put 12 in, you will use them later on. Recommend OM4 at least, or OS2. OM5 is only needed if you're going to use 40 G-base W. It's as it is, let's say, a proprietary standard or a fiscal. It's I don't know how much it will be, let's say, implemented, but it's the only case in where OM5 fiber would be worthwhile. Otherwise, OM4 or OS2 would do the job, and use LLC connectivity to make it upgradable from 10 to 25 to 50 gigabits. So what we have in place in BARPA for that, well, we have tight buffer cables from 2 to 24 optical fibers with OM4 or OS2 fiber type. And we have the complete LC connectivity range with patch cords, adapters, and of course, pigtails. But not only we have solutions if you want to implement Wi-Fi 6, but or 6E, we have solutions for every type of installations in copper, from category 6 to category 7A, in shielded and unshielded constructions, depend on where you want to install it and how you mean you want to have it to electrical magnetic interference. We have indoor and outdoor cables. In optical fiber, we go in multimode from OM2 to OM4 fibers, and OS2 for multimode, Also G657A fibers are available in outdoor and indoor constructions for building and campus backbones. Also, we have a very complete rack and cabinet range for servers, distribution, wall mount, and open racks. It's very difficult to find a rack that we don't have in our range. I think if I counted well, we have over 125 different items or different type of racks on stock. If you count the different type of racks and also the multiple configurations of height, depth, and width, and different types of front and rear doors or lateral panels. And of course, also the needed accessories for these racks and cabinets. But in BAPA, we not only sell products, we can give you a whole range of solutions, technical consultations and assessments. I even support you or help you with your network design. We have superior quality, and that certifies our Delta certifications. We can give you 25 years warranty on your installations. And of course, don't forget our trainings in the BAPA Space Academy. Okay, and that was it from my side. So thank you for your attention, and we can go to the questions and answer part, Pedro.
Okay, thank you a lot. You have to rest a little bit, exactly. Drink a little bit of water to put your strength again higher. We have some questions. We are waiting for more, but I think that we can use the ones that we have now to answer. Can you close your screen to
One moment.
the presentation? Yes, of course.
Perfect.
Now we are bigger than okay. Let's go. I have some questions. I can pass the first one. Is from Abel, and he are asking if we at this moment are there tools to testing and troubleshooting Wi-Fi 6 already? Are there tools for testing and troubleshooting Wi-Fi 6 already?
Well, I know there are tools for Wi-Fi 6 deployment preparation, and if I'm not wrong, there are already Wi-Fi 6 test equipment or Wi-Fi 6 ready. I don't know about Wi-Fi 6E, but Wi-Fi 6, I'm quite sure there are test equipment ready. I can find out. But
yeah, okay. But BARPA don't have now. This is important. Okay. We have another one that is Lyra is asking for Lyra, and Lyra, we have Lyra with the information that we can use in Cat6a FTP. Okay. But can we use it in Cat6 FTP or even in UTP, for example? This was a question also.
Of course, the cable, the conductor diameters that are allowed in, or we can use with the LiDAR connector, make it possible to use it with even with stranded cables, so patch cord cables. So no problem to use it with Cat6 or 5E cables.
Or even in UTP solutions.
Yes, of course, you have to take into account that you won't have the shield protection, but you can use it as a shielded connector into a UTP system. If you take a look at the connector in your PC, the RJ45 connector in your PC or in your laptop, you will see it's shielded.
Always.
Always, even if you can use it with a shielded patch cord or an unshielded patch cord.
Yeah. Okay. More questions. I will say to you concerning the Wi-Fi 6E. We will have another band with a larger spectrum, but when 6E become mainstream, the network will be overcrowded, and we will have the same problem that we have with the current 5G gigahertz. No. Okay. This is difficult to answer. No.
This is a thing like the prediction made of in the 80s when you got a PC that had a hard disk, and that was a hard disk of 20 megas. You said, wow, I will never have enough data to fill that up. Can you imagine this at this moment? We say, no, okay, good hard disk, 1 terabits. So the thing is that Wi-Fi 6E will increase incredibly the capacity of connecting equipment to it. So, so on the same access point. That doesn't mean it doesn't have a limit. It has, but we will need a bunch load more of equipment connected to it to really get to the limit. And when that happens, then Wi-Fi 7 will come up and
probably will be always
will duplicate it or multiply that by 10 or by 100. That's the industry. This industry looks like.
Another one also about 6E. Will 6E be capable to support faster internet speeds or just the same that the frequencies that we already use?
Taken into
this is the imagine we have some questions. Probably all the questions that I will make will be connected, you know, because are many.
No problem.
Okay.
Well, take into account that 6E is used within the network. Imagine you have an office building with 10 floors, and on each floor you will have, well, let's say 5 access points. So these access points will go with a 10G link to the distribution rack on the floor, with the backbone to the main telecom room or data center, and there we will have the connection with the outside world, the internet world. So what it means probably that, or what it sure means is that the backbone has to be big enough to absorb all the traffic that comes from the access point or goes through the access point through the backbone towards the data center. Some will be local traffic, some will be internet traffic. Yeah. What doesn't mean that we probably also need better internet links. But Wi-Fi 6E will not make internet better or worse, because it's not directly connected to it. So, yeah. Sometimes, especially when you talk about 5G, sometimes there is a little bit confusion because we use the word 5G for a lot of things. We use 5G for the 5 gigahertz band, okay, and we use 5G for the 5th generation of mobile telephony.
Yes.
Okay, and these are two completely different things, have nothing to do with each other, and we call it 5G. So sometimes there can be, let's say, a little bit mix up with these two terms, just to clarify.
Okay. Let's try another one. Can we surpass distance limitations of Ethernet cables with better cables? Have a stable connection with more than 100 meters. You understood?
Yeah, well,
distance limitations with better cables.
We have, yes, the answer, the short answer is yes, we can.
Yeah,
like
we can.
Obama said, yes, we can. And I will go to explain it now.
Yeah, okay.
The standards like ISO, CENELEC, or TIA, they say we need to make 90-meter permanent links and 100 meters channels. So what is the purpose for that? This is to make these links compatible with IEEE applications, like we see fast Ethernet, gigabit Ethernet, 10 gigabits Ethernet, 40 gigabits Ethernet, 25 gigabits Ethernet, and so on. So, and IEEE defines, okay, I launch now 10 gigabits. So, and they say, okay, for 10 gigabits, I need at least category 6A.
At least.
At least. If I have a higher category, it's better, but at least category 6A. So whenever IEEE launches a new protocol, it will say what category it needs. So if we install this category following the ISO, CENELEC, or TIA rules,
normative, exactly,
then we are sure this new application will work on our installation. But imagine now that you say, okay, I have in a parking lot, I have a control of a barrier.
Yeah.
And instead of 100 meters away, it's 120 meters. So, and I install it with Cat6A outdoor cable, of course, because
yeah,
somewhere outside.
BARPA apps.
Will it work? Yes, it will work, because a barrier that only has to detect a license or a card that you use will never use 10 gig. So so even if my cable is 10 gig capable, I will never use it on that speed. I will use it with 100 megabits or as high as probably, to have a smooth traffic. So then I can forget those 90 or 100 meters respectively and make bigger links.
Of course, but if you have to certify that point,
because your test equipment will test it against TIA, ISO, CENELEC standards. It's not meant for that. So if the only thing, if you test the link, and it's 120 meters long, and the only thing that is not passing is the length, because it's out of range, you can use it perfectly. I have tested links of 140 meters made with Cat7 cable, Cat6a connector, with 1 gigabit transmission of simultaneously voice and data. So voice over IP and data work perfectly.
Yeah. And
Depends.
we also test cables from BARPA Cat6 in with the normatives in Cat6a, and a test pass. For that, we can know that it's possible to have better cables can give you a better results when we make a connection. Yeah.
Correct.
Okay. Let's try the other one. I have more 1, 2, 3 questions.
Okay.
Metallic trays and better cables that dissipate better the heat. Will that influence the speed of the connection or just the durability of the system? If you understood?
Yeah, yeah, understood.
Okay.
Well, let me see. It can affect the speed because Ethernet is wonderful and horrible at the same time. I will explain.
Okay. Okay.
Ethernet is a very strong protocol because if I have a 10 gigabit link, if the two equipment I connect and are both 10 gig capable, but the link in between is not good enough, they will try to connect at 1 gigabit. If they don't succeed at 1 gigabit, they will try to do it on fast Ethernet. And if they don't get it, they will go down to 10 megabits. And hey, in 10 megabit it works. So if I send data from one equipment to the other, data will come over. So apparently the link is working.
Yeah.
But it's not working on the maximum.
Well,
So
yeah.
if I have a big temperature rise and my link is, let's say, on the length limit, it can make it that the speed they auto-negotiate is going down and down and down. So at the end, we'll have less speed. So I pay a bunch of money for a beautiful access point that cost me a kidney. And then I use bad cable to make it work like I use an access point of 15 years ago.
No, don't do that.
Don't do
Yeah,
that.
don't do that. We have also here a question. Does BARP have crimp tools? Crimp tools. I can answer this one.
Yeah.
We are making at this moment so many different products. We are adapting to different countries all over around the world. We are working with them, and each country have its own specificity, and for that we are studying many different products now and new products. For now, crimping tools is not the main priority, and who knows, in the future we can do it, but for now we don't have it. Crimp tools, you can use the crimp tools that you already have in the market. When we talk about crimp tools, I'm thinking about the 110 system tool to crimp, the cron crimping tool, but this one we don't have it now. Okay. I already, yeah.
One comment on that. If
Okay.
we are going to use POE, make sure you use a crimp tool that crimps all the conductors in one time, not individual, because then we can create, if we have a beautiful cable that has very little resistor imbalance, what but we create resistor imbalance on the connector side.
Okay, okay. This is
This
very important.
crimp tool that use all of them.
Another one for you, but I think this one you can do another webinar about this theme. That is, what's Leonardo idea about 5G? 5G is not 5 gigahertz. It's 5G
Telephony.
system exactly.
Okay.
When another one connected with the first one, when we can have it in full force, in your opinion, about 5G, and when we will get it.
Okay.
What do you think? This
Um,
is a situation that you can talk a lot about one day or more.
how many time do we have? Well, 5G. It's a beautiful development, 5G, because it will allow a lot of different applications. 5G, it's not about internet speed. It will have a little bit more, but it's not the main issue about 5G. 5G will be implemented on very local scale, very small cells that and operators are already and equipment manufacturers are already making trials on it in different scenarios. That's also beautiful. But we will have now we see mobile telephony with big antennas on the top roofs and on a long way the highways also with big towers. Main part of 5G will not be that way. Okay, they will use these towers to reuse, let's say, the infrastructure, but we will have 5G antennas on light poles. We will have 5G antennas
Everywhere.
on bus waiting areas. We will have 5G antennas. Your own ONT in your house that the operator puts in your house will be a 5G antenna. Well, so the deployment will be completely different than what we have till today in mobile telephony. What will bring us is that we will have, as it has a very small latency, control systems will be very easily to implement. So at this moment with mobile telephony, the latency, that's the time that it takes to, I give here in command to go somewhere to execute it and come back with the result, in 5G is really, really fast. This means that it makes it very easy to have real-time control, make cities much more intelligent.
Cars.
Cars, but not only cars, also the traffic lights. I mean, it's very common that you have a huge long road in a city with 100 traffic lights, and you have to stop on every traffic light because your traffic light is green, you start, and when you're almost before the next traffic light, red. That's not efficient. That's not efficient. So with very fast telecom systems, we can manage these the traffic. So at the end, we will reduce traffic jams, we will reduce contamination, and so on. So and we are not able to think about what it's gonna be change in the way our cities are in 5 to 10 years time. They will be completely different, and I hope for
I
better.
believe. I believe.
So it's 5G can represent a revolution to telephony that is equivalent than when we got from the Nokias to the smartphones. And
Yeah,
I
yeah, yeah, yeah.
and I
Was
love Nokia.
yes. I
Yeah.
love also Nokia. I worked there. Okay. I think that was fantastic. All your information. I think, and I want to thanks everyone that were here with you, with us, principally with you. And I think that we are in the end of our presentation. If you want to say something more to the participants, use this moment.
No, just thank them all for their patience. It must be really tough to support me here during almost 2 hours.
No, it was very nice. I learned a
Thank,
lot, and I
thank you
think
very
that the
much.
other ones also.
I hope
Thank
so.
you a lot. Thank you a lot, Leonardo. Thank you, everybody. I want to use also this moment to say again to follow us in the Instagram, LinkedIn, Facebook. This is normal. We will do other webinars about different themes and different methods. I think that will be nice to get your presence also. And thank you all the countries that I don't know well exactly the countries that were here, but I hope that you like it, our Leonardo presentation and Barpa presentation. I think that's all. Thank you another time, and thank you, Leonardo, for being here. Okay,
Welcome.
thank you a lot.
See you next time.